Welcome to the All Things DER podcast, brought to you by AEIC. In this podcast, we dig in, define, and discuss where the new energy economy is heading with electric industry leaders and explore all the ways that distributed energy resources can modernize and improve our ever-evolving power grid. Thank you for joining us.
Welcome to All Things DER podcast. I'm so excited for today's conversation. We have Dr. Daniel Haughton, who's the Director of T&D Engineering Support at the Arizona Public Service. Daniel, welcome. I look forward to this conversation and digging into all things DER. Why don't you introduce yourself to our audience?
Thanks for having me. So I'm the Director of Technical Engineering Support at Arizona Public Service, as you said. In that role, I oversee teams working on grid and energy innovation projects, GIS, so the mapping information systems, and a grid modernization team, as well as a small team called Technical Projects that provides, they're sort of the internal consulting group that provides a lot of technical support, especially to our generation organization, working on things inside of generators like system exciters, power system stabilizer tuning, generator modeling for transmission planning and operations functions. Very interesting and eclectic team working on high priority items across the organization. And so thanks for having me. Glad to share today.
Yes. One thing great about having this opportunity to host this podcast is I get to meet a lot of my peers in the industry. And something for our listeners just to remember, the cool thing about the electric utility is because we all have our own grids within our own territorial geographic space, we get to share all of the great, cool things that we're doing together and really kind of do it collaboratively and, learn from each other. So it sounds like your role is very parallel to mine here at Duquesne Light, where ultimately our goals is to further innovation, implement the new technology, and just really embrace grid intelligence, right? So enhance that visibility,
Absolutely.
Control, and the overall power quality and reliability. So I'm so excited to hear what you're up to over there in Arizona. And so another unique thing about utility space is even though the phenomena of the power grid, of how it works and how it's interconnected, it has grown very differently in the different regions. So here at Duquesne Light, we are a transmission and distribution only, so we have wires only. However, Arizona Public Service, you guys own generation, transmission, and the distribution, right?
That's correct. We're one of the few vertically integrated companies that's still in existence. So we own everything from our own utility-owned generation fleet, have quite a number of power purchase agreements with plants that are built in or around our service territory, and manage a pretty large transmission and distribution portfolio and about 1.3 million customers across 11 of the 15 counties in the state of Arizona. So largest investor-owned utility in the state of Arizona, peak load about 7,500 megawatts, just a little bit larger than that. Growing pretty fast. Arizona has been for the last few years quite an interesting place with all the growth and the population, the shifts in population, where we see pretty significant growth in both the commercial industrial load sectors with manufacturing and warehousing and semiconductor manufacturing locating in the state, data centers and other kind of interesting customers we see coming to Arizona. And with that, you have a lot of people moving from other states to come here, right? It's a great place to live and work and raise a family.
And that's what I think is so exciting about these conversations. One, I think it's good for listeners to baseline, your 1.2 million customers, 11 counties across the state of Arizona, where it's always sunny and shining, and really you're building out this grid for this increasing population. Whereas over here in Western Pennsylvania, 2 counties, half the customers, we still have the same challenges, maybe not as rapidly, maybe not as fast. So for me, I get to kind of look to the West and learn about what all you're doing. So, and with that, I'm going to just throw a question over you, maybe a softball. What do you foresee, with everything happening in regards to the opportunities, aka maybe challenges, of transitioning to embrace this new clean, quote unquote, technology of how it's really interacting with the distribution system that you have today.
Absolutely love that question, because part of our jobs, right, is to think about not just the utility as it exists today, but the utility as it's evolving, and how customers and users of electricity will interact with and utilize our product and our service well into the future, right? I think most listeners would agree that if you think about life 10 or 20 years ago, we're probably more dependent on electricity now than we've ever been. So the need for high reliability, always on and available electricity, you want to be able to depend on your electricity provider to know that even during a storm, right, you're not going to deal with extended outages. You're relying on utilities to be there for heat in the winter, and in places like where you live, for cooling in the summer. For places where I live, right, Arizona, we get to 120 degrees in the summer, so you can't really live here without air conditioning and cooling. But you think about electric vehicles and electrification, well, what that means for the needs of reliability from the electric system. You think about decarbonization as a focus, not just here locally, but nationally and internationally, the push for providing electricity from zero carbon resources, and just the changing expectations from customers of interacting with businesses differently, right? They don't just want to have a utility provider pay a bill and not know anything about how electricity was provided, right? They want to be a part of the solution and aware of all the little, intricate details of what are happening, not to the level that the utility personnel are, but they want to know, right, when there's an outage, when's power going to be restored. They want to know, that we're investing in keeping the system reliable, when and where we're making, major investments and upgrades, information about their bills and how they can interact with us to either manage or reduce their bills, right, extract more value from the utility, right, a whole host of different things that I think are really, really great opportunities for us as utility employees to think about how we shape the utility for that potential future world.
So the one thing I'm picking up, and I think all of us are kind of pivoting, we built this grid over the last 100+ years with the customer in mind. And as it evolved, really the 70s, 80s, we tapped out in the robustness of our generation, on the how large it can be, how efficient it can be. And then we took that bulk generation that we overbuilt probably at the time, and then started building out to serve our customers in a way that was safe, reliable, and efficient. And over the last 40 years, really, we've been driven to be more energy efficient and kind of use the capacity that we built in the grid over those decades. And now, there's this fundamental awareness of us as beings that the technology that's at our fingertips in regards to how we shop and how we purchase and how we communicate is instantaneous, and it almost seems that there's many in the know. But when it comes to the electric utility space, we were not really in a position to really dabble or be risky rolling out that new technology to have that information at our fingertips. So I think there's like a growth experience happening with our customers and ourselves to really educate and bring that awareness of what we need to do to be able to serve that instantaneous awareness of how the grid is interacting with our customers. And so, one thing that maybe showed up in your space more rapidly than, say, the utility was prepared for was residential solar. And, I remember, hearing and watching, as your residential solar went from hundreds of applications to now tens of thousands. And I guess, you've been a part of that journey, and maybe you can share a little bit about, what were those lessons learned that you learned from when there was just hundreds that profoundly helped you enable the tens of thousands, if that makes sense. Because I always have there's this general thought that you don't need to know until you need to know, but you need to know right away, pretty much. So what are those lessons that you could share?
Yeah, no, that's another very interesting question, and thanks for asking that. So, in the state of Arizona, we've seen over the last 10 years or so really rapid customer adoption of residential rooftop solar, and even utility scale solar is part of that. So, in the late 2010s or mid to late 2010s, we had a state mandate renewable portfolio standard to achieve 15%, clean or 15% renewable by 2025. And so early on, the utilities invested in large wholesale utility plants. So 10 to 30 megawatts for or quite a number of them, and then one really large 250 megawatt solar thermal plant, all of which are still in operation today. Customer-owned renewable was also part of that mandate or that process, right? So the customer-owned renewable, was always expected to be a relatively small slice of the overall resource portfolio. So back in 2010, let's say. And what we've seen happen in the market, regarding residential rooftop solar, is the market evolved to provide different pricing options for customers. So there was the solar leasing model where customers could get solar at zero down, pay over time. You had, other models. There's quite to this day, there's quite a, robust residential solar marketing machine, in the state of Arizona. And so we learned a lot of these lessons looking at Hawaii and California. So, you look to the west, you talk to us in Arizona. We look to the west as well, right, to Hawaii and California. So we saw the potential rapid growth and adoption happening. When I got involved in the residential rooftop solar space back in about 2016, we may have had 30 to 40,000 residential rooftop solar systems. And today we ended 2022 with over 150,000 customers with residential solar or solar on their rooftops.
Wow.
That's more than 1 in every 10 customers that has a solar system on their roof. And of course, from the engineering perspective and looking at the distribution grid and how the distribution grid has to evolve to accommodate these large volumes of large penetration of solar, right? You really think about you have to have, along with the customer application process and making sure that your process is quick, efficient, scalable, right? Because customers are applying. We went from a couple hundred a month to on average now we're probably upwards of 1,900 applications a month. Probably have over 22,000 applications a year or somewhere in the range of 22,000 for rooftop solar applications, right? So your processes have to be very, very quick, efficient, and fast to be able to process through those applications. There's a fixed timeline that you have to follow because customers aren't gonna, wait months to hear back. Is this application approved? What do I need to do to interconnect and install? Right? They want very quick turnaround. The installers want the same thing, right? And then you look at it as building a different type of relationship with the solar customer, with the rooftop solar customer, because when the customer gets rooftop solar, that solar system generally only works when they're connected to the grid, right? So it's
Right.
not an off-grid, island installation. It's something that's operating. We see a lot of power shipped back to the distribution system. At one point, over 50% of energy from those systems were being fed back to the grid because customers will install for their summer usage or peak summer usage, but during our mild spring and fall time periods, right, these systems are shipping a lot of energy back to the grid. And so how the legacy grid was built was not necessarily built to accommodate this bidirectional two-way power flow, have voltage control and all these other technical details managed at the point of interconnection or the far into the feeder, right, far along the feeder. Utility personnel generally had, operators in the control center would have visibility of maybe the substation and some elements on the circuit, but not a whole lot.
So-
We've made great strides in our investments in providing. Really, you have to provide the visibility of what's out there and what's happening visibility to how the grid is operating. And then, we're still working to see how we interact with those devices differently, or how you interact with customer-owned devices, and interoperate with utility control devices, circuit control devices, think regulators, cap banks, switches, how you do in design protection systems with high penetrations of solar and pockets on the circuits. And the visibility, you start with the visibility, then you get to the control, and then our plans are eventually to look at how you optimize the system with these customer resources. But it's much different again, right? We talked about earlier the central station generation, right? Utility grid was built, a few large power plants, right? A transmission system to ship power to the load centers, and then distribution networks to distribute the power through those load centers. Now, in terms of residential solar alone, you're talking north of a gigawatt of rooftop solar, being produced at the grid edge, so at the customer premise. And a lot of that at some, times of the year being pushed back towards the sub-transmission and the transmission system. And so managing those flows requires a lot different infrastructure mindset, operations mindset, and that visibility, control, and intelligence layer, right? And so those are all the things that the departments that I oversee are very heavily invested in. Brings up conversations on DER management systems and ADMS modeling systems, the GIS systems, right? The systems of record for where things are, what they're doing, what they're set to, what their settings are, and how they're operating and managed over time.
So we're very acronym heavy here in this industry. So for our listeners, when we say ADMS, DERMS, GIS, ultimately, these are the advanced technologies that are required to be implemented within the utility space to have this full situational awareness that you're speaking of. And I think, for our customers and really our regulators and really those that want to know, is the grid ready for electrification? I think one of the key elements that we have to do as an industry, and why this podcast exists, is that education. And I think, what you're talking about, right, in the lessons learned, you went from hundreds to now 150,000 of your customers. That's, 10%. Yeah, that's what you said, 1 in 10. And so
upwards of 10%, correct.
So when we, here's the grid, me as just a customer, there's a pole outside and maybe a can up there, and there's a wire that drops in, and just an individual wants solar. It shouldn't be that hard, right? Put solar, connected on. And I think as a society, we have to start thinking of the grid again as something that serves all, and not this one, like we're each individuals and we should be cared for individually, and somehow get the communication out and the education that the grid needs to be really shifted with the wholeness in mind. So that when you have the 1 in 10 customers, you have to realize that one person impacts 9 others, right? Your neighbors are a part of this equation of how we prepare our grid for that ultimate reality that you're already facing. And here over in the East and some of the other utilities that may not have that kind of proliferation of generation at the edge, it's still that you, us, the designers, the operators, the planners of the grid, I mean, one application could have profound impacts to the next 10, hundreds, and thousands. So really gearing your team up in the technical acumen and really giving the data and the models to all of your members probably was like the crux of the beginning of you to even, step in this direction that you just spoke of. I think I'm just kind of reiterating, because I think we take for granted that we know that like this change that seems small to maybe the outsider looking in, as you just laid out, it impacts the overall design of the infrastructure, how we plan that design, how we operate it, how we maintain it, and then how we communicate that out to the edge, which is our customers, profoundly changes almost everyone's job internally,
Absolutely. No, you're absolutely right. I love the way that you kind of explain and summarize that, because, those are some of the challenges that we see. But I'll say it this way, right? How we've looked at and how we've kind of planned for, DER and some of these system changes, you start realizing that customers want something, right? So they'll adopt these technologies because they want something, and we need to figure out what that something is, right? Customers also don't want to be told that there are, limitations, or that, hey, your neighbor got solar, but now you can't get it because the circuit's full, right? And so there are issues that are, we'll call them new and emerging within our industry, that organizations like ours have had the experience with and have had to try and figure out and manage through. And your comments on the customer education and expectations is definitely something that you've got to focus on and manage going into the future. There are regulatory sort of hurdles to manage and overcome as well. And there's also the, call it the business model and financial modeling implications of some of those things, right? Because one of the practices I think that, help DER get to scale, you can see is, not sustainable in the long term. If 1 in 10 customers has rooftop solar, right? What you're compensating for that customer for the energy sent back to the grid, it's something that you have to manage and measure and be really aware of. But you got to start thinking, what happens when I get to 50% and 60% and 80%, right? That you can't be paying above market for, energy from solar, because at some point, right, the 9 customers who don't have the technology, are paying for the 1 customer that does adopt the technology. And so that's one area that I think utilities have to balance and be really measured in approach, because from the regulatory perspective, right, you got to have the structures in the organization. The utility has to be healthy. All customers have to be financially whole, and the customers who are adopting technologies should be able to adopt those technologies. And so we want to create, sort of the technology agnostic, future grid with the right rates and signals and incentives to get customers to adopt technologies and utilize them in a way that, not just maximizes or helps, benefit the individual customer, but, helps benefit all customers on the grid at large. And so, like with rooftop solar, right, where we see, changes in sort of the future, state or the future scenarios as customers are adopting electric vehicles, you have to be really aware of when they're charging, how they're charging, and making sure that you're not sort of exacerbating problems, right, as they're adopting batteries in their garage, right, launching and managing utility incentive programs to encourage those customers to have those technologies respond to grid events and be used and dispatched for, managing the entire grid and not just necessarily optimizing for, your monthly bill or your individual need, right? But that customer who's, leveraging or allowing us to leverage those technologies have to be kept whole financially. And then, utilities you have to have the visibility and the controllability in place to say, well, don't charge or discharge the battery now. We need it to discharge, maybe an hour or 2 or during this window, because that's when either the system is, peaking, or when that individual feeder is peaking, right? And so, yeah, very, very, very interesting and very, very dynamic. Not the utility of the past for sure.
And I guess I just, you bridged that gap. So I think, here we are, the industry, and I've been in the industry for 18 years. And just, I remember, being a brand new engineer into the power world, is my leaders and my mentors talking about the industry is very cyclical, right? So you kind of have these highs and lows. And I remember sitting in the chair hearing about large wind and helping the planners in the California utilities study the impacts of such wind. And then very quickly it was like, here comes solar. And then it was battery storage. And then it was it was utility solar, battery storage, residential solar. But now you just mentioned it's like bucket of 5. Now we have to understand how's EV charging and now discharging vehicle to grid. We have to have communication to the edge to be able to play and understand how we can use our customers' energy in a beneficial way for them as well as us from the grid. So that's your demand response, energy efficiency. Then you mentioned your battery energy storage. So that's kind of the Achilles heel, storing energy for later. That was a fundamental tool, I guess you could say, that
Yeah.
Edison and Westinghouse did not have 140 years ago when planning the grid. And then just generation in general, like not even solar, but CHP backup, whatever that may be.
Yep.
So here we are, the planners of the grid, not really trying to understand, okay, here comes wind, then here comes solar. Here it's like here it all comes to the edge of the grid that wasn't designed for. When we put it that way, it sounds kind of hopeless, but I think you tapped into a few things that makes me hopeful is, and maybe you can agree, is having the data and the models to bring that intelligence and that insight to those that need it to help make these creative solutions move forward. And that
absolutely
is part of your realm too, right? Is advancing those technologies.
So I wanted to pull on a thread that you just introduced there, right? Because the thing that makes me the most hopeful is that there are people like us, right, the utility side professionals who see everything coming all together and understanding how it all plays together, right? Because your EV advocates are just focused on EV and electrification. Your solar advocates are just focused on, their individual technology, right? Each sort of stream or individual technology or technology provider or service provider is really just focused on how can I maximize, potential in my one area. But I think, the role and the goal of the utilities has always been to provide affordable, reliable, cost-effective, or affordable, reliable, and just
safe.
What was that?
Safe,
affordable,
reliable.
Safe, affordable, and reliable. Yeah, all starts with safety. So safe, affordable, and reliable, electricity, and that mantra still holds, but the pool of potential resources that you have to balance and manage to be able to provide that service is changing, and that's what's changing really quickly, right? But I think as the utility professionals, we're the ones that have to educate customers, educate regulators, and provide that visibility and that vision for the future that says, here's how we see these things all fitting together, and here's how we can accommodate them, make sure that we have safe, make sure that we have reliable, and make sure that this is still affordable, right?
And then throw on top of, we also have to be environmentally sustainable as well as resilient, which it always has been there, but it's becoming more of a focus. And that's
right. That's absolutely right. And
just exciting.
And that on top of the backdrop that we didn't talk about, right, which is we see in Arizona just the impacts of climate change really in a meaningful way, right? Longer, hotter summers, more severe wildfires and wildfire seasons, right? The longer, hotter summers means it's drier, means it's communities are more susceptible to outages from a number of different issues. Winter storms, right? More frequent and probably worse impacts in some cases.
I think we had
and one of the things, like some interesting statistic that that I recently found out was, like, some of our service territory. So Flagstaff, Arizona, gets about the same annual snowfall totals as Buffalo, New York, right? And so we've got to we have to manage these low-lying desert environments that are 115, 120 degrees during the summer, but also these high elevation northern territories that experience like really severe winter storms. And so there's really a polar opposite response that you have to make. But planning, you still have to plan, you still have to operate, and you still have to provide safe, reliable, and affordable service to all of those customers and communities.
I have to say, I think that maybe the most fun fact that you shared is that you get as much snow in Flagstaff, Arizona as Buffalo, New York. Just kidding. There's lots of fun facts we shared. Yeah, I think, and actually our last podcast guest was, chief scientist for NOAA, Dr. Kapnick. And we invited her to our AEIC annual meeting to literally share all of the data that they have and that we have available to us to really make some of these decisions. And it vastly is changing. And really for us, again, being the one that can see all of those technologies and how the grid actually works come together, it's more important for us to have that data so that we can make those planning decisions of our grid. I think you and I could talk for hours, especially on this topic, since it's probably things that we think about while we're at the dinner table, and it's hard to shut off. But just to kind of wrap up, what do you see? We spoke a lot of it, but really some cool, innovative solution that maybe your team or one of your teams have embraced in the last year or two, and you look forward to kind of carrying that forward into the next year.
So, we see, the potential for EVs and electrification, specifically vehicle-to-grid technologies, as being a potential game changer. Today, you have, the stationary batteries, like you can buy a, battery for your garage and provide, backup to your home during an outage. When you really think about a lot of the EVs that have been announced that are available commercially, but probably still pretty hard to get, right? A few years from now, when they're more widely available and you can show up to the dealership and drive one home when you want to, I think you'll see a much different level of interaction. And that EV battery is usually orders of magnitude larger than that stationary battery that you can have in your garage, right? So envision that world where you've got solar on your rooftop, you've got this truck with a battery large enough to power your home up for, maybe a day or two on the hottest or coldest day of the year, right? For us understanding how those technologies work and how they interact with the grid and, going through the entire process of technology evaluation, demonstration, product development, developing those products with stakeholders and regulatory, partners, to provide those, incentive programs or those enrollment programs for being able to manage those customer devices, I think will be a really interesting one. And then others that we're looking at, I'm going to maybe shift that question over a little bit to the bipartisan infrastructure law and the funding that's being made available there, because I think that provides a really interesting opportunity for utilities to even think about and contemplate, right? What are the new and existing technologies, programs, and projects that help us focus on, grid resiliency, reliability, hardening the system against natural disasters, or forest fires, worsening storms, summer heat, winter storms, that type of stuff. But also thinking about other technologies like microgrids, right? How can we provide maybe some more hyper localized, reliability, resiliency, like take a community, right? Just a neighborhood. Can you have a community center that you can guarantee is maximum uptime, even when there's an outage, there's somewhere for the community to gather, either stay cool during the summer or stay warm during the winter, be able to charge up their cell phones and laptops and have access, because really data and access and technology is not just the utility need, right? It's sort of the customer need today, right? Think about you being disconnected from your phone for a week. Like that would be devastating, right?
I could do it.
Then,
no.
And then other technologies, we think, like looking at grid forming inverters was another one that was really interesting on our list of items to evaluate, because the potential, like we see this renewable future happening, right? The residential has been pretty dominant in the state of Arizona for a while. The growth in residential, rooftop solar, but to meet our, long-term clean energy commitment and decarbonization targets, right? We're going to invest heavily in utility side, utility scale, solar, wind, clean energy resources. That means a lot more inverter-based technologies being online at any given time, and fewer of your traditional synchronous machines, rotating mass technologies being online. And so we've got to really think about how do you create the the inertia, the frequency response, the ride through capability, the fault tolerance, right, from these large inverter-based technology resources, things that you get by default with synchronous machines, that you don't get with inverters, right?
Right.
How do you make those inverters respond or behave or look more like the traditional machines? Because that response of those traditional machines is basically the principles of grid stability that this entire grid was built on, right? So as those phase out, we still have to keep some of those services viable and available from these new crop of technologies. And the lessons we've learned from Texas and from California and from Hawaii as well, is that we have to have these technologies, or we don't understand today. We don't understand everything about how solar inverter technologies work. You might think you do, but right when there's a disturbance, you realize, oh, there's some setting, there's some mode, there's some configuration that wasn't contemplated. And as a utility industry, right, we are the ones that are responsible for understanding the technologies and making sure that we can keep that safe, affordable, reliable, system up and running.
So more or less, you're everything in the kitchen sink you're excited about. No, but if you think about we as, what you're faced upon is understanding electrification of vehicles and really that moving load and that new source of energy storage that maybe isn't here today, but is coming, just as if solar wasn't here in the 70s, but it is here today. And then also the idea in studying how inverter-based generation at bulk can be used similarly, or what is it? Inertia smersha? No, I'm just kidding. What's it called? Fictitious inertia? But there's a different word for it.
Synthetic
inertia. And what is that? What is it? How do we make it? And how can we really move that forward? Are kind of like your two big sinks that you're super excited about. And with IIJ funding available, really taking an opportunity to use this to our advantage. So as of anything and all things DER, it's a very large topic, and I just want to thank you for sharing all that you're doing. And I look forward to continue this journey with you and those other peers in our industry. So maybe we'll probably be back for more in 2024, and you can share all about the electrification of your fleets or whatever your large challenges were in this year coming. So with that, thank you, Daniel, and I wish you a new happy year.
Happy New Year.
That's a wrap for this week's episode of All Things DER. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.